Whatever the energy is entering the system, same energy should leave the system. That's the only energy can neither be created nor destroyed. So whatever the energy given to the system, so same energy has to come out. How do we consider the set? First it is the which is the first energy, let's say potential energy, mg z1. We are considering the height, right? Mg z1 plus next the kinetic energy. Here volume and velocity both starts with V. So that's why we'll keep the velocity with C1. Velocity will be represented by C, whereas volume by V. So V1 square. Potential energy, kinetic energy plus flow energy. How do we represent that? Flow energy is nothing but pressure with volume. So volume is, here it is, the cross-sectional area into length it has traveled. Okay. So P1, A1, L1, sorry. Volume. Okay. So volume itself is P1 plus whatever the heat is added to the system. Did I miss any term? Enthalpy. I hope I have. So first, the potential energy. Potential energy. Next, the kinetic energy. This entire thing, the enthalpy. This is flow energy plus the internal energy. Both put together it is enthalpy. Flow energy, internal energy, both put together, enthalpy, and heat added to the system. This is the input to the system. What is the output? Again, same potential energy plus kinetic energy enthalpy, flow energy plus internal energy plus the work. This net be tracked. Potential energy, kinetic energy, flow energy, internal energy plus the heat input to the system. Output to the system is same. Potential energy, kinetic energy, flow energy, then internal energy U, U2 plus the work done by the system. So once again, we look into the question paper. A fluid system undergoes non-flow frictionless process, changing its volume. So initially, V1 is by meter cube, and last V2 is 2 meter cube. Pressure and volume, they are related by the equation P equals 20 by V plus 2. What is the output? So you'll get the pressure in terms of Newton per meter square. So first thing, what is what is to be done? Task, what is the task given? We need to calculate work output. Okay. So substitute this V1 into this equation, given equation. So P1 is equal to 20 by V1 is 5 meter cube plus 2, we'll get it in 20 by 4, 20 by 5, 4 plus 2, 6 Newton per meter square. This is P1. P2 is 20 by 2, 10 plus 2, 12 Newton per meter square. So this is P1 and P2. What is the task given to us? Work done. Now, can anybody tell me which is this Yao equation use model? Whether it is constant pressure, constant volume only, volume work done is 0. So we will not bother about that. Whether we have to use constant pressure, whether we have to use constant temperature or polygon, Yao use model. Anybody? We have not solved any problem, something which is a fundamental. All problem, whatever the problems we have solved, either it was constant pressure, constant volume, or constant temperature, or molecule. This is the first. What is the solution? Yes, madam. Class, look at the board. When you come across a situation when you are not able to decide which process, then in that such cases, go to the fundamental definition. What is the fundamental definition of the work we have taken? Work done is equal to integral PdV between the limits 1 to 2. Okay. In this, both pressure and volume both are varying. So what is the strategy or how we can, whatever that variation, how to accommodate that? Express this P in terms of volume or volume in terms of pressure. Since they have given the equation P is equal to so and so, I'll substitute the same in that equation. Here it is 20 by V plus 2, this is pressure, into dV between the limits 1 to 2. Can we go for integration? Definitely. How? Very simple integration. So first 20 by V dV plus 2 dV. So we'll integrate the entire substitute. Just I have multiplied that dV with the whatever the differential with both the terms. This entire thing. Now what is the integral? Execute the integral equation. 1 by v dv. Excellent. So 20 natural log v between the limits 1 to 2. Here, okay, plus just dv between the limits 2. Here, since we are integrating between the limits 1 and 2, initially v1 is 5 meter cube. Final it is 2. Sorry, initially it is v1 5 meter cube. Final volume is 2 meter cube. All you have to do is just substitute the same. So work done is equal to 20 ln of, initially this is V2 V2 by V1 बराबर. When we substitute, yes or no? Okay, plus 2 V2 minus V1. Sorry. So this is between the limits 1 and 2. 1 ಯಾವುದು? ln of 5. V2 is 2 meter cube, right? V1 is 5 meter cube plus 2. V2 is 2 meter cube. Can anybody get me the answer? Here it is minus 3 into 2 minus 6. Whereas here it is ln of, will get a negative term. Minus 18.3. So it is minus 24.325. What will be the unit? Since it is work done, it will be in the joules. Yeah, done. So this is a special case. When you are not able to decide which process, what is that you have to do? Go to the basic definition. What does the minus sign indicate? That work is done on the system. Very clear. Look at the board. Volume is decreasing. 5 meter cube to 2 meter cube. Volume is decreasing, whereas pressure is increasing. Mean to say that entire compression and expansion. When we are compressing, there has to be work is done on the system. So it is negative. Work is done on the system. That's why negative. Negative sign indicates that work is done on the system. Negative sign indicates that work is done on the system. Shall we proceed? Last, we can proceed. Yeah. Okay, turbine operates under steady flow condition, receiving, sorry, receiving steam at a following state. P1 pressure, it is 1.2 10 to the power of 6. Next, temperature, T1 is 188 plus 273. Is to 461 Kelvin. Okay, next. Enthalpy 2785 10 to the power of 3 joule per kg. Velocity, velocity C1. Velocity C1, 34 meter per second. And Elevation Z1 is 3 meters. Right. Next, same at outlet condition, pressure is 200. Yes. 10 to the power of 6 Pascal. Next. Yeah. Okay, yes, not given, so don't worry about that. What he has given is enthalpy H2 is 2512 joule per kg. Next, yes, 100 meter per second. Very good. Next, yes, heat lost. Class look at the board. Here is specifically has mentioned that heat is lost to the surrounding. Whenever heat is lost going outside the system, what is the convention we follow? Minus 29 into 10 to the power of 3 watt. So we need to calculate power output or we need to calculate power output or work done, right? Since it is in joule per second, it will get it in watts. Moving on, steam flow rate, yes. Okay, steam flow rate, mass flow rate, he has given as 0.42 kg per second. Okay, moving on. Look at the board. First, write out the steady flow energy equation. What is that? Mg Z1 plus half. Very good. MC square plus P1 U1 plus Q is equal to plus half M C2 square plus P2 V2 plus U2 plus work. In the data, he has given enthalpy. The enthalpy will here this entire term is H1. This entire term is H2. Yeah, definitions what we discussed. Right, moving on. First, see this problem. Solving this problem is just it will take 2 minutes. All you have to ensure is the uniformity in the units. If the units are uniform, it's just addition and subtraction, nothing else. Look at the first one, mgz1. Mass is 0.42. 0.42 into 9.81 into z is, first one is 3 meters, right? Just multiply this. Per second, meter per second square plus meter, right? So it is kg per meter second square, mass into acceleration, Newton meter per second. So I'll get it in joule per second. Yeah. Mass is kg per second. Acceleration due to gravity is meter per second square. This is meter, 3 meters. Mass into acceleration is Newton. What is left out? Meter second. So Newton meter per second, Newton meter is joule divided by. So what do I get? Watts. This is nothing but watt. Right? Am I right? Okay. Shall I erase this? Shall I erase it? Here. Acceleration due to gravity. Of 0.42 into C1 is CS there, initial velocity 34 meter per second square, 34 meter per second. So this is mass is kg per second. This is meter per second. This is square ala. So this is square. Illi, can I write it as kg per second into meter per second into meter per second? Mass into acceleration. Mass into acceleration. So this is nothing but Newton per force. So I'll get it in joule per second. So this is in watt. So this is in watt. This is in watt. Plus enthalpy ಅಂತ ಹೇಳಿದಲ್ವಾ ಹೌದಾ? What is enthalpy given? 2785. What is the unit? Unit ಏನು? Kilojoule per kg. ಹೌದಾ? ಇಲ್ಲಿ ವ್ಯಾಟ್ ಇದೆ. This is also watt. I have to make it watt. ಹೌದಲ್ಲ? This is joule per kg. I need to multiply this with mass. Mass ಇಂದ multiply ಮಾಡಬೇಕು. Then only we need to multiply this with the mass into enthalpy. This with the mass and this again with the mass. So this is 0.42. So this is kg per second, joule per second. So get watt. Realize. So watt. Everything is in watt. Okay. Last heat. So it is heat lost. So minus 0.29 minus 0.29 into 10 to the power of 3. Everything is in watt. Left hand side complete height. Everything is in watt. Yeah. Next, coming to right hand side. Again, same 0.42 into 9.81. This is zero elevation. Z2 is zero. Z2 is zero. So this is entire term is zero plus of what is the velocity? 100 meter. So 0.42 into 100 square plus enthalpy is H2. 2512 into 10 to the power of 3 into mass plus W. That's the only term. This is in watt, this is in watt, this is in watt. So I'll get W in terms of watt. This, if at all you take up this, if you check the unit correctly, answer per late. This is for 10 mark, 10 mark. So uniformity, check the units. That's it. One point.